Morning, everyone. So welcome to the Newton and H2 number 4. So in this chapter, we will discuss about the stereolithography for repairing tools. So main outcome of this class is to know the repairing and what are the tools which are required to avoid the errors. To rectify those, we need to follow some techniques to remove the overlapping of different geometries undergoing the STL file repairing errors. So here, what is meant by the .stl? So .stl is nothing but STL lithography, and it is a standard tessellation always. So standard tessellation always means it is involving some triangles, involving some hexagonal figures which will be overlapped during the meshing file. So you all know that there are three stages generally observed in a particular process. Okay, so here you can see the three important designing steps. So first one is we need to create a 3D file by using any CAD software. Then we need to go for meshing. So meshing is an important process which we need to give the core structure fine, okay, or medium mesh. Okay, so here due to using of this meshing technique, the 3D object can be converted into number of facets. Okay. You can see there are various purposes by using the .stl file. So during the 3D printing, this is the common format used for 3D printing, and where it can help to create a physical object. It will convert this total physical object into number of layers. Generally, it can be seen in 3D printing. And CAD and modeling software. So here you can use many type of CAD software packages. You can import and you can export STL files. So after making a 3D model, we need to go for simulation. So in the meanwhile, these simulations will be done in the industrial or design industries. They will perform this by using different analysis softwares like ANSYS or XCAD. So there are many type of versions they will use, and they will perform finite element analysis. And not only those, you can use for flow analysis or CFX by using ANSYS software. So they will perform structural and thermal analysis on a particular 3D object. So after that, you need to get some visualization of the particular 3D object. There we can identify what are the stresses, what are the temperatures will be raised during the giving of different load conditions. So however, after completion of the total geometry, these files are need to be converted, and they will be given in the particular dialog box. You will get these type of file formats. The first one you can see AutoCAD drawing files. Generally, it will be given in .dwg. So, and you can see the second one, CATIA V5 art files. So these two are general softwares. We can save it the 3D geometry in these .cat or .dwg. But you can see IGES files. .stl files and binary files, step files you can see here. So these are all the different geometrical files. After saving in this file, the 3D object or 3D model, whether it is drawn in CATIA or AutoCAD, is converted into number of different tessellations. So that's why they given standard tessellation promise. So you can see the different examples of using different STL file repairing softwares. So these are the six important file repairing softwares. The first one is MeshLab. So this is an open source where if you have the 3D model, you can perform the repairing after build a 3D object. So here you can identify the automatic common issues of generating holes and non-manifold edges. So here non-manifold edges is nothing but so the different edges will be attached or overlap. So here also you can see self-intersecting triangles. If there is any geometrical error when giving the tolerance by mistakenly, you can get the self-intersecting triangles. So the NetFab, it is a famous, mostly used repairing software which is developed by Autodesk. So where you can edit or repair and you will get the fine 3D models. Okay, it is available in the internet. Okay, there is a Blender that is also a animation software where you can use it for different types of applications. And as well Tinkercad 3D Builder and Make Reprintable. It is also a free software. You can directly check out the errors for different 3D models. So here you can see the types of repairing software where they perform and identify the errors, which is shown in here in red color. So we can see this is a beam, some type of beams under different loads at particular point or a particular section, cross section. These are to be repaired and go for again for 3D design, that is called pre-processing, where you can build the damaged part. So you can see there are different triangles and different types of structures, geometrical structures. So in American English it is called tessellations. So there is a sphere, cube, and there is a pyramid and different types of example you can see. So here the boundary edge can be repaired by using NetFab, where you can attach the surface or you can edit that particular part, and you have to give the nodes in the form of a programming language, and then it is converted into a mesh mixture where it is totally be perfect. So after that we will go for the fourth one. So it is a correctly designed and exported HTML file. So here in green color you can see it is a particular type of toy by using some stereolithography operators. They have performed, and before going to building a model, they have rectified this red color zone into a green color by attaching different layers. So here you can see there are two types of methods. One is auto repair method and make solid method. So in these two, there are simple steps involved in this. You have to load the STL file and you can go for mesh mixture where you have to select the particular hole. So this is one of the error. So you need to refill it and you can delete the option by using simple terms which is given in the particular softwares. So this is the interface that you can see in the right hand side, where you can give the file options, edit options, and you need to give the filters. So this is the top task toy, where at the top of that there is a hole due to giving the improper geometry nodes. So simply you can dump this particular import by using import file. Already we have saved in STL. So again we need to give for repairing. So by using these options. So finally we need to delete that hole. So there is a function we will be used that is called analysis. Okay, we can rematch those layers, and there you can see inspector option where you can give the number of nodes and types of tessellation, that is type of mesh. So after clicking those, you can go for auto repair all functions. So automatically the transparent layer will become a totally green color, that will show it is automatically filled a layer. So you can go for next procedure. So this is also similar thing make solid method. Here you have to give the mesh densities. So that is one of the property. So type of thickness, type of number of nodes, that is the cell size. The cell size will be finer, so you have to give the mostly tolerance value. So thereby you can go for different settings. So this is one of the methods which can be seen. So what is the another procedure? Generally, the back end of this STL file is having this ASCII style format. So here they have used some binary codes. It is nothing but a text-based programming. So it is stands for American Standard Code for Information Interchange. So here the binary code and ASCII format, these are the standard codes. You all know the binary format. So there are some bit operating depends upon the 8-bit, 12-bit, 7-bit. So by that we need to give for coding as 0110. So here we can give a simple queue. So here is the format. Each and every coordinate need to be identified. So in STL format, you can see we need to give the tolerance of 5 to 6 digits so that it can be very finer. So if you see the orange model, so it is having the cell size is higher. So we need to give a finer mesh, so there you can get a perfect model with a better surface finish. So this is the perform of this particular STL file, where you can see the back end. So each and every node will be identified, and triangular nodes having 3 vertex, and the is perpendicular to the screen is also having another facet. So it may be formed with different coordinates. So you need to examine those coordinates. So then you can rechange the program, and you can automatically rectify that error. So you can see this is the format of the code. You can see here for ASCII they are having 80 bytes. Okay, so there are for every each and every code for each step. So during this functioning of this code, these will be displayed in the two format, ASCII STL file format involving different nodes, and binary STL file format will be saved in number of bytes. So in this example, we have seen these type of referring softwares. So here you can see what are the advantages. So by using ASCII, so mainly it is human readable. You can easily read and rectify the text. and it is having larger size file due to the number of nodes and facets, and it is somewhat it take a longer time to load and will be processed in 3D software. And when coming to binary, you can see it is some compact and not human readable. That's why, because it is having some 0 and 1 operators. Depend upon the byte size, the codes will be saved in this type of code numbers. So here these are typically used for 3D printing and CAD application. Their file size and loading speeds are critical. So generally in the ASCII format will be more convenient for rectifying and debugging the errors by any human. Okay, so you can see the structure. For a header, it will be saved in 80 bytes, and when coming for facets, you can see it takes 50 bytes in length. So you have to know for what is the load to save the different types of steps involved in the binary format than ASCII format. So these are the normal vectors. Each vertex it will be saved in 12 bytes, and so finally these are the different types of techniques which you will need to perform during the STL file repairing software. Thank you.